Good morning, Algebra 2. Today's class, we get to start Chapter 15. And another one of these small chapters. And the section we're going to look at today is another type of function. As if you guys are saying, oh, when are these functions ever going to end? Well, they keep going on. So section 15-1 is we're going to be defining and evaluating logarithmic functions. And this is new to everybody. You'll go into a whole lot more detail in pre-calculus. So we'll just pretty much cover the basics of logarithmic functions. And the essential question is telling us what a logarithmic function is. So if you look at the essential question, essential question, what is the inverse of an exponential function? Now, we've done exponential functions in the last two chapters, where in this case, this is an exponential function where we have a base b. And once again, if the base b is greater than 0, it could be an increasing one or a decreasing one, like a decay or a growth function, but this is an exponential function. All right? Some base raised to some power. But if we take and find the inverse of this exponential function, we get what is called what is called the logarithmic function. All right. Again, we're not going to really go into too many details on that. You just have to remember to take that as a statement of fact. Now, again, before I move on, what we're talking about in this section is going to be found on page 12 and page 21 of your HD&Cs. All right, now, so before I go there, I want to show that to you. Again, if you look at our sheet here, again, if we go back and look at the difference between an exponential function and a logarithmic function, they're inverses of each other. Okay. Now, again, this is when you see the example we're going to do in a minute, you're going to say, that makes a lot of sense. Up here in this part right here, this is two types of exponential functions we dealt with in the last section. The reason I'm showing these two, because these two and its inverse can greatly be seen on the calculator. Okay, so here is two exponential functions. The first one is a base of 10, that's this one right here, and also has a base of e. And if we were to find the inverses of these two, okay, the inverse of this one becomes a log function, logarithmic function. And if I take and find the inverse of the exponential function, that is what we call a natural log. And you're probably asking yourself, what are these buttons over here on our calculator? Well, over here, if you look at the log button, that deals with a logarithmic function of base 10. So again, here is our function of base 10. The inverse of this gives us the log function. So in other words, you see how the graph goes this way, its log function is going to go this way. That's the inverse. Now again, when we do an example, you're going to say, yeah, I remember doing that. So here is base e. Again, if you look at your calculator, here is the base e, and the inverse of that is what we call the natural logarithm. All right? So we're going to be seeing a lot of these examples. And something else that we're going to see later on, and it's going to take a little bit of practice doing it because these two sections are, this section or this chapter is relatively new to you guys, deals with couple of things. Up here at the top of the page on page 21, there's the graph of exponential functions. Once again, this one is a growth function. See, it grows. This one is a decay function. It's decaying. And then down here, this is your exponential function. And over here is a decreasing exponential function. All right, no big deal. This part right here, we're going to talk about it in a moment. Exponential function can go and be rewritten as a log function. and vice versa. A log function can be written as an exponential function. You'll see in a minute. A couple of rules that we'll run across. A couple of things about common logarithms and natural logarithms, and probably one thing that you're going to get so tired of looking at is these laws. The first one on the left is your exponential laws. Again, that is nothing new. That is a pre-algebra. That's an algebra 1 concept. Those are your power rules. But now we can apply the power rules to logarithms. And this is something, this part right here is going to be very new to you guys, okay? And not only can use it for logarithms, we can use it for natural logarithms, and we'll hang on to other thoughts about that later. All right, so with that said and done, we can go and start defining what is a logarithmic function. So in the Explorer part, again, I'm hoping you guys are going to take the time, well, I'm counting on it, taking the time and reading this through. And what I've done here before I really got into the problem is I highlighted something, because I've already stated already. The inverse of an exponential function, again, that's y equals b to the x. If you get to find the inverse of that, that's called a logarithmic function. Now, all this other written stuff is what we'll talk about. So what we're going to do is in the Explorer part is, well, what makes a exponential function a log function? Well, the first part here, I have a couple things set up. I'm going to do two things here. If you look at the diagram here, this right here is this function right here. You with me? Let's see. This function right here is the graph that we see. All right? This is a exponential function. It has a base of 2, and it looks like a growth function. Okay, ignore this part right here for right now. Now, if you look at here, we know that it's going to have an inverse because we already stated that an exponential function has a inverse, and it's going to be a log function. Okay, so that means it falls along the line of it's going to be reflected across y equals x. Now, we did this a long time ago, and if you look at your points of this exponential function of y to the 2x, we have the point 3.8. And the inverse of 3.8 is 8.3. So x is 8, y is 3. You're going to probably say, oh, I remember doing this stuff. That is the inverse. So the inverse of the 0.24 is 4.2. The inverse of 1.2 is 2.1. The inverse of 0.1 is 1.0. Trying to be neat here. The inverse of negative 1.5 is 1/2 negative 0.1. The inverse of negative 2 and 0.25 is 0.25 negative 2. And then that right, please forgive me. Let's see, that right there is the graph of that inverse function. And that graph, which is an inverse function of this graph, this is a log function. Now, what I'm going to do next is we'll be seeing plenty of these. Okay, I just showed it to you graphically what it look like. But what would that function look like? What is the inverse of this function? So again, we have to go back and do a little recall. Finding the inverse, you take your function you're dealing with, let the y become an x, and your x become a y. And from here, okay, we need to solve for y. In other words, in order for us to get this to become a function, we got to solve for y. It's got to be y equals. So now this is a new concept. What we got to do here is we want to get this y by itself, so I have to get rid of this base 2. So to get rid of this base 2, I've got to take a log of that. So I have to take the right-hand side, I've got to take the log base 2 of that. And if I take the log base 2 of 2, it becomes 1, and I'm left with y. That's one of the rules. Again, it'll come out later on. And then since I multiplied the right side by log base 2, I have to do the same thing to the right side. So now we have done what we asked you to do. So log base 2 of x equals y. This part is your inverse, so we can write it as an inverse. So in other words, we can write it in this form or this form. So the inverse of this exponential function will be this. So this right here is your logarithmic function, which is the inverse of this function. All right, now at the bottom of the page of the Explore part is pretty much explaining this part, but tying it into as a log. Now what I have done here is I'm going to show you how to do this by your calculator, because now this diagram you can tell right off the bat, just to let you know, we already know that this is the inverse. We already know that at 0.25, if you look at your diagram at x is 0.25, we know our y is going to be -2, okay? We know that. Just by looking at that diagram, we will know it's going to be -2. All right, so if we go now to the next one, what is the inverse or the log of 0.5, or in this case, log base 2 of 0.5? So we know we go to 0.5, we know x is going to be -1, and we know it's the inverse of that. So this is going to be -1. And you should see a pattern, okay? Log base 2 of 2, so in other words, what is the y value when x is 2? It's going to be 1. All right, now based upon what I've showed here is how we do that using our calculator. Again, what if we don't have this graph? What if we don't know what the inverse points are? We don't know those. How do we find out what these answers are? Well, I want you to go to your calculator, okay? This is new, okay? I want you to go to your calculator. I turned it on. So let's find, in this case, I want to find the inverse of 2, which is in this case is, what is the log base 2 of 2? Did I write this one down wrong? No, I didn't. Log base 2 of 1. I think I made a mistake here. No, that's no big deal. I think I made a mistake somewhere. Yeah, that should have been 1. Yeah, that doesn't make sense. Why did I put a 2 there? Log base 2 of 1. There we go. Sorry about that. So when x is 1, y is 0. We made a mistake, Mr. McConish. We'll fix it right now. I missed a turn. It's 0. Because again, if you go here to this function right here, when x is 1, y is 0. That's my mistake. No problem, guys. Sorry about that. All right, let's go here to the next one. So let's take and find log base 2 of 2. Well, we already know over here it's going to be 1. But how do we do it using our calculator? All right, turn your calculator on. I want you to go and hit the button Math. Okay, in the Math part, I want you to scroll all the way down till you get to the symbol that says log base parentheses and hit Enter. All right. Now your blinking light should tell you what base you're dealing with here. In our example right here, we're dealing with the log base of 2. So we go 2. And then in this part right here, we let that value become 2 and hit Enter, and we get a value of 1. Now this is by using a calculator. We could have just done this whole part right here just by looking at our diagram, but I'm going to show you a couple things at the same time. All right, so let's go to the next one. How do we find the log base 2 of 4 using your calculator? Plus there's another way of doing this too, and I'll tie that in a few moments. Go to Math, find the log base parentheses, Enter. We know we have a base of 2, and we want to know what it is. Log base 2 of 4, and it is 2. Again, we could have saw that right here in the diagram. There's another way of doing it too, and I'll talk about that in a moment. All right, so log base 2 of 8. Again, Math. Log base. Base is 2. We want to find it at 8, and it should be 3. All right. First problem, they already had the graph of the exponential function of a base of 2. They identified a few points. if you take the inverse of those points, that will give you the graph or the points of the inverse function. And that inverse function of this exponential function is going to be a log function. We'll do enough of these, you'll be able to see it. Down below here is first part in the green. We just looked at the graph and found the inverses. So here in this first one, if x is 0.25, what is the y value? So if this is x is 0.25, we know the y value is -2. Then the bottom part here that we just did a moment ago, we used the calculator by using the math, okay? All right, now let's go to the next page. The next page is, like I mentioned a few moments ago, there's another way of doing this without looking at it graphically and without looking at it using your calculator. All right, and this is the part of the problem that we are going to run across. Okay, converting between exponential and logarithmic forms of equations. All right, so if you look here at this part, this is an exponential equation. We have a base b raised to the x equals a. We take the time and do the inverse of this, we are going to find that the logarithmic expression of that is log base b of a is x. Now this part right here is something that you've got to really get into your brain and to memorize, because what we're going to do is not only are we going to go from exponential to logarithmic, we're also going from logarithmic to exponential. All right, we could have done that up here in the top part. So what I did is I took an example, okay, just an example. Here I have 2 cubed, we know is 8. 2 to the third power is 2 times 2 times 2, we know that's going to be 8. This is an exponential example. Over here, this is a log example. So in other words, in this problem right here, we're taking the exponential and writing it as a log. Now again, if you go back to your log, it says log base b. So again, you got to go back to your exponential, and your base is 2. So log base 2 of a. So if you go back to your exponential, your a is what it equals to. So log base 2 of 8 has got to equal whatever x is. So log base 2 of 8 must equal 3. So again, you got to be able to see how you go from exponential to log, or from log to exponential. And once again, they are inverses of each other. All right. Look at this. Some of the stuff is going to take a little bit of practice, and I think you're going to do fine. Okay. Let's go on to the next part. What I really would like you to do is I want you to take the time, look at example 1 on page 747. I want you to read it through. They go in words of what I just talked about on the previous page. They show the work down here. I want you to take the time and look at that, because one side is exponential, the other side is logarithmic, and you need to be able to go back and forth. Okay, so I want you to go back, stop the video, and look at explain 1. And then something else I want you to do. I want you to stop your video, and I want you to do letter B. Okay, and then I'm going to show you how to do letter B, and then we're going to do your turn. Okay, so let's look at it. Okay, you probably stopped the video, you probably read it. Now we're on page 748. Let's make sure you guys are able to see this. All right, once again, we're taking an exponential equation, b to the x equals a, and we're writing it into a logarithmic expression, which is log base b of a equals x, and vice versa. So if you look at this problem right here, they gave us a exponential equation, and we want to write it as a log equation. So go over here, we know it's going to be log base b, but our base here of our exponential is 3, of a, which in this case is 243 has got to equal 5. Exponential to log. Just look at it. Exponential to log. Log base b of a equals x. All right, now this problem right here, the next one is we're in a log expression and we want to go to an exponential. So if you're exponential, you got to ask yourself, what is your base? Well, it's going to be 4. Log base b. B is your base. Okay? Your a, your 1/64th is your a. So we know that this problem has got to equal 1/64th. And in the a here from the logarithmic expression is, once again, the a over here. So again, log base 4 of -3 equals 1/64th. That's how you do it. Exponential to log, from log to exponential. Remember, exponential is a exponential function. Its inverse is a log function. They're inverses of each other. All right, now the next one, letter B, we have the base of 3/4 raised to the r, and we equals s, and we would like to take that and put that into logarithmic form. Okay? We want to go from here to here, so we know our base is 3/4. We know our a, in this case, is the letter s, equals, in this case, whatever a is, in this case, it's r. Again, 3/4 raised to the r equals s. Y'all with me? All right, the next one, we want to go from log to exponential. Your base is 1/5. Again, your x, once again, is what it equals to in the log, which in this case is w, equals v. That is going from exponential to log and log from exponential. Now what I need you to do is, I'm not going to go over the your turn. You have the solution manual for that. So I want you to go back and do the your turn and look at the answers on the your turn. Let me do one more thing on this video. And it deals with explain 2, is how do we evaluate log functions by thinking in terms of exponents. All right, so if you would like, look at, oops, I better cut some of these off because I don't want to do all, I don't want you to see everything. Okay, you able to see everything? Part A, they show everything in detail. I'm going to do part B and do those multiple parts to give you an idea of what's going on here. All right, so this first one right here is they gave us our function. F of x equals log base of 1/2 of x. And what they want us to do in 3 parts is find out what our answer is when x is 4, find out our answer when x is 1/32, and find our answer when x is 2 radical 2. Now I'm going to do it 2 ways. I'm going to do it in terms of thinking of it as an exponent, okay? And then I'm going to show you how to use your calculator. All right? So first things first, number 4, first part of B, we want to find f of 4. So we take our logarithmic function, anywhere we see an x, we let it become 4. Now what they want to do here is, this is in a log expression. What they're going to do next is they're going to write this as a exponential expression. So 1/2 to the y equals 4. And we did this stuff a while back. We notice here that the left side has a base of 1/2, but the right side does not have a base of 1/2. So we have to go and do a little bit of power rules to get a base of 1/2. So I already know that 2 squared is 4. And also, we got the same time, I've got to get this base right here of 1/2 to be a base of 1/2 here. So I have to rewrite this. So in other words, 2 as a base of 1/2 is going to be 1/2 to the negative value. That's called the negative exponent rule. So now this part right here, we now have two expressions that have the same base. So if we use the 1-to-1 property, that means y has got to equal -2. So in other words, all this part right here is in terms of using exponents or in your power rules. So f of 4 equals -2. Now, we can also do this same type problem by using our calculator. So once again, we know that f of 4, we already know it's going to be -2. But in our calculator, how would we do that? So f of 4 will equal, go back to your original function, is log base of 1/2 of x, but we already said x is 4. So what we can do next is fire up your calculator, go to math, locate your log base rule. We know now that our base is 1/2. I'm hoping you guys are seeing this. I'm not looking at my camera. It is 1/2. So base of 1/2 or 0.5 of 4 equals -2. So our functional value was, so f of 4 we know is -2. All right, now I think I'm going a little bit over time on my video. So what I'm going to do is I'm going to pause this. No, I'm not going to pause it. All I'm going to do is I'm going to show you this part. Pause your video, and I want you to take your time and write that down. Remember, this part right here is just taking our log and writing it in terms of a base using our power rules. Same thing here. And then down below, I didn't do the calculator work, but if you do the calculator work, you'll find that this will be 5 and this one will be -3/2, or in other words, -1.5 in your calculator. So that is the first part of this section. I'm going way over on this one. All right, I'm gonna stop, and the next video will get more applicational. Thanks, guys.